Hello, everyone, and thank you very much for joining our Unlocking the Cloud Operating Model webinar with the head. My name is Scott Heller, and I'm with the HashiCorp marketing team, and I'll be your host for today's event. On behalf of HashiCorp and our partner head, we'd just like to start with thanking everyone for taking time out of their day to join us. Today, we will hear from Michael Wood, HashiCorp's field CTO, and Tim Curlis, Ahead's Chief Architect of DevOps. Michael is going to discuss the implications of the cloud operating model and present solutions for IT teams to adopt this model across infrastructure provisioning, security, networking, and application delivery. Tim will walk through how Ahead integrates the HashiCorp toolset and some best practices for successful digital transformation. I'd like to note that the webinar is being recorded, and we will make the recording available to you after some post-processing. This usually takes a couple of days, and we will get it to you via email. We'll have some time at the end of the event for a live Q&A section. If you have any questions during the event, please utilize the Zoom Q&A portal and enter your questions. We will address them at the end of the presentations. With that, let's go ahead and get started. Michael, go ahead and take it away.
Welcome, everybody. So happy to have the opportunity to chat with you today. I'm going to move actually pretty quickly through this material, about 20 minutes, give or take, so that we can get to some practical application with the Ahead team. So we'll get a bit more detailed on application of these approaches. But I do want to touch on the fact that there are a couple of tectonic shifts that are affecting our market, our segment, the things that we're trying to accomplish as groups within IT. And those are primarily focused around things like automation and the fact that the public cloud has unlocked some new capabilities for us. Very much on demand. It's sort of disintermediated a lot of what it typically took us to start building software. Rather than standing up racks of servers in a very static way inside of our four walls of the data center, we now have many, many options for the way that we get services around IT. So things like networking, storage, compute, et cetera, the cost of those on kind of a per core, per minute level continues to decline. And with that, we have some really interesting models to drive self-service. And this opens up a lot of opportunities from an application standpoint in that as an IT team or as an IT function, as we serve our business partners, there's a shift from systems of record into more system of engagement. And as we talk about things like digital transformation, we're oftentimes talking about this mode of engaging with our customers in new and unique ways. Things that we see as being highly dynamic, moving quickly, experimentations at very low cost to see if we can serve our customers better in this way, learn something in production, and then do it again. And so the systems of engagement we see as certainly going to be operated in a cloud and dynamic fashion. We're going to roll those very quickly at very low cost, learn and iterate on them quickly. Now, that is less true of our systems of record. Like we are typically not going to see massive iterations with our, the way that we process our quarterly financials as an example. So we do see the press, especially around those systems of engagement. And the companies that are doing this well are the companies that are succeeding in the marketplace. And so we're seeing things like the leaders in innovation in various verticals are doing so by deploying code faster, easier, quicker, shorter lead times, less costly experimentation. So they're able to deliver new experiences quickly and stay ahead of their competition. So the implications around the cloud operating model are diverse. So if we're talking about things like provisioning, typically when we were provisioning, we were doing physical servers and then we were housing VMs on top of those servers. And typically those VMs had the same general lifespan as the physical servers that they sat on. In some cases, the VM could outlive the hardware, with vMotion and those types of things. I was able to kind of preserve the running state of the virtual machine, even as the physical hardware aged out. And so we weren't looking at something super dynamic in the VM world, and it took us over 10 years to make that transition. But certainly as we look at cloud and what AWS and Azure and Google and Ali and these other cloud providers are bringing to the table, we're seeing things like, obviously containers has emerged, much more ephemeral workloads, things that are moving around quite a bit, maybe appearing just when they're needed, like in a serverless kind of context. But generally, we have this mixed environment where we also have these long-lived chunky VMs and then lots of little workloads that are provisioned across those in the public cloud. So a bit of a shift from physical, static, hardened to dynamic, moving, changing. And then if we look at security, we have this shift in the way that we think about security, where we can no longer think of everything outside of our network perimeter as bad and everything on the inside of our network perimeter as good, because the threat model is really more attacker on network these days. As we interlink all of our cloud assets and resources, and we're working with SaaS providers and so on, we have all sorts of holes that get punched in our perception of what our network perimeter is. And so we have to move away from these high trust concepts that we've typically enforced on our internal networks into much more low trust, kind of service-based networking, identity-based security, no clear perimeters. We have to make that shift as well. And when we talk about networking, it's really hard to separate security and networking one from another. They're very linked, if you will. We have to think of, if the perimeter is going to be moving around, how do we manage our network and connectivity and firewall rules and access privileges and so on and so forth. And so if we were dealing with a very static kind of environment where IPs were very long-lived, we were able to do things like work with firewall rules, which are IP1 can talk to IP2, et cetera. But where we're dealing with a lot of ephemeral workloads, it's very, very difficult to control network access using IPs, especially if they're changing all the time, or I don't know what they are until the workload spawns. Those kinds of things can cause us some significant challenges at the networking tier. So we have to look at ways that we can manage them more by a service name or identity, as opposed to dealing with static IPs. And then finally, as we talk about running application workloads, we're no longer talking about standing up a server with a VM and then building that workload to run on that VM. We're thinking more like there's a fleet of resources available to me, and I want to schedule work to be done on the fleet. I don't necessarily need to know where it's going to be provisioned. I just want to consume resources out of this pool. And so a big piece of what's shifted around deploying and running applications is really that concept of leveraging the fleet as opposed to building for dedicated infrastructure. Now, I think one of the more obvious transitions that we're seeing in the marketplace is this concept that multi-cloud is really going to be a reality. You may be dedicated to a single public cloud vendor or something along those lines. You may be trying to keep the stack fairly simplified in that manner. But even operating your public cloud and your private cloud infrastructure, you're still a multi-cloud kind of environment. You'll have a set of operating principles that you use internally, and you'll have another set of operating principles that you use in the public domain. And as we see, all of these clouds are vying for the ability to serve you. They come up with complete stacks to help you do all of the things that we were just talking about. Provision infrastructure, provide dynamic security and policy, things like that. But they end up being very siloed to that particular cloud. So if you're using CloudFormation in AWS as an example, and their Lambda functions and so on, you're very much dedicating a skill set around that particular cloud's implementation of that stack. And then you'll have another team which does Azure as an example, and another team which does GCP, because they're different technologies, different kind of approaches to solving those individual challenges. And so a lot of what we do at HashiCorp is take a look at this as a workflow challenge. So yes, there's a lot of different technology for us to choose from, but where Hashi takes the approach is to say, Provisioning infrastructure is a workflow, and it's a ubiquitous workflow. It really shouldn't matter what the cloud technology is that you're going to leverage as the end running state. What we want to do is help you to automate the delivery of that infrastructure, regardless of what the cloud infrastructure is. We feel that this is also a huge benefit to our customers because it simplifies that kind of approach to be domain focused as opposed to technology focused. And so your IT operations team begins to focus on building streamlined dynamic processes and allowing for greater flexibility for the business to pick and choose cloud techs that make sense for a particular application or a particular application portfolio. The same thing would be true of security. We use Vault there. So Terraform is the provisioning product. So you can define infrastructure as code in Terraform and you can provision to any cloud. The same thing would be true of Vault, where you have a centralized identity broker that I can then flex my security identity management across all of my clouds and deal with things like secrets and encryption as a service, et cetera. And connectivity between services would be something like Console. So again, that workflow across all clouds. And then finally, we have Nomad for our job scheduling capacity. And we'll talk about those a little more deeply as we go. So the shift from the static to dynamic is really this concept of moving. We believe that what most customers are really trying to do is not necessarily the technical shift to in other words, we're not moving to public cloud just to move to public cloud. If we're moving to public cloud, we're doing so because it's providing additional benefit in the form of self-service or dynamically available infrastructure. I don't want to wait weeks or months for a VM to be presented to me or hardware to be provisioned or storage to be allocated, et cetera. I can get those in the cloud very dynamically. And so I have this demand, not just for, it's not necessarily about the underlying tech, it's about the self-service experience. And so if we're talking about traditional data centers, we're essentially moving away from ITIL, ITSM ticket management systems and more into API-driven self-service. And so if we're talking about digital transformation, I know that's an overloaded term, but when we talk about digital transformation, we're talking about that modernization of the front office applications to serve clients in new and interesting ways, as well as an operational shift towards self-service and dynamic consumption via APIs, along with, yes, incorporating public cloud into my IT capabilities so that I can deliver better results for the business. So if we're framing up the challenge, it's not just about the tech stack, which is kind of what I've been hitting on. When we talk about something like the cloud operating model, we're really talking about looking at an existing company's view of how people are skilled up. They're specialized against individual technology stacks. So if you're a Cisco admin, you are super deep on how to manage Cisco infrastructure. And then you centralize kind of a set of KPIs around that capability so I can measure and prove that I'm doing a good job. And then you have the culture which emerges out of that communication and organizational setup. So I'll have tickets and I'll use things like a ticketing process to buffer those individual teams so they're not just buried with random requests coming in, and I want to organize the work and measure against those KPIs. So I establish systems to underpin the process by which work goes across these specialized teams. And actually that's kind of ITIL, ITSM. And our first reaction to how do we break out of this is to see if we can find a unicorn. And I'm sure you've heard the terms of a unicorn, but the idea of someone who is an operator who understands all of IT inside and out from end to end. And therefore I have someone who can sort of dynamically address any issue, no matter what it is and how it comes up. Quite frankly, we're not sure these individuals actually exist. You're always going to have a strength in a particular area and less so, or more of a generalist in another area. And so our recognition is that the reality is that there's going to continue to be a specialization of talent. It's just not going to be tech driven so much as it's going to be domain driven. And so in the domain of a developer, that particular constituency is receiving more autonomy and responsibility. in DevOps world, you build it, you run it, you're on the hook for the operational viability of the product that you release. So you have service ownership. It's a very fulfilling role as a developer. I get to create value and take it to my customer. But it also imposes greater risk from an operations standpoint, because I wasn't responsible for mean time to resolve before, but I am now. So more, along with that power comes more responsibility. And so to facilitate that role for the developer, we may do things like embed an SRE for operations. So at HashiCorp, as an example, we'll embed an SRE to ensure that operations is being handled consistently across all of our product teams. But their goal is to make sure that they are providing those safety rails, those guardrails for the developers to ensure that they can experiment without doing things like exposing the company to risk or introducing fragility into our systems or things like that. And then we have things like networking. Networking becomes much more interested in service level networking. The idea that that our hardware load balancers and firewalls, as an example, need to become application aware. So if something comes in and out, I want a dynamic response. I don't want a ticketed response. And so their goal is about driving self-service around the networking competency. And then finally, security. So rather than security being a manual audit with Word docs at the end of a process, we want to shift left with security and make it part of the entire process. And so we're looking at ways to ensure that that security specialty can be represented throughout the software development lifecycle. And we'll talk about that a little further. Generally speaking, we're seeing this expressed as policy as code. And we'll hit on that as we dig in just a little bit more before turning it over to Ahead. So as we're looking at process and how we get these folks to act we want to incent all of these different constituents to work as a team much more collaboratively and not necessarily, I don't know, I jokingly refer to it as kind of sociopathically. I want to really care about everybody in the organization. So I want to drive empathy by getting these various teams of people to work together, and then also work out processes that allow those teams to collaborate to deliver capability. And so typically, if we're looking at an ITIL process, we're saying that we have tickets that we file. A developer has an idea that they want to get to market. They file a ticket, they wait to get a server provisioned, whether it's a VM or whatever that infrastructure is that I want. I'm going to wait weeks to months to get that done, and then I'll wait weeks or so for the firewall, and then I may wait. Well, I may wait longer for the firewall than I do the load balancer. But the point is I'm making these ticketed requests. It goes into a queue, and sometime later I get a DNS or something that I asked for. And and this is because we focus on those tech silos. I mentioned the Cisco admin before, where I've got a ticket coming into the Cisco team in order to handle routing, as an example. And then what happens is over time, well, we add Palo Alto networks, and now I've got a software load balancing team and a hardware load balancing team, and I have a firewall team, and then Palo Alto networks. Now I have software firewalling and so on and so forth. So I have all of these additional teams just within the networking domain that we ticket against in order to get pieces of work done. And over time, that organically builds itself into, for this one major telco, 72 tickets that a developer has to file before they can get a piece of work done. And ultimately, it takes us 10 months in drag time, because we're spending so much time either chasing a specialty group to get something done, or what have you, for us to deliver value. And so we don't feel that success of adoption of public cloud is necessarily adding another ticket to provision a VPC within AWS or those types of things. Like, yes, we're going to have some cloud specialists within the organization, but rather than owning that technical domain and having a gatekeeping process for access to that technical domain, we'd like to move more towards a process domain. So infrastructure provisioning is a process domain. I don't care what it is that you're provisioning or across what clouds. I want to have a good, clean operating model for the way that we provision as a job definition. And so we'll have IT operations, as an example, will own the provisioning stack. and will automate that for the rest of the company to consume. And then out of that, they would then drive self-service API access to dynamically build or request the infrastructure that is available to be provisioned. We're talking about security as being another layer of that, and ownership of the process domain. It would be ownership of access control, if you will. Think of it as a workflow around identity and access control and cryptology. So if we're talking about DevOps, this is really the shift that we're talking about, is developing these APIs for consumption by the development team so they can move very, very quickly. And so the new system to underpin that process is really where HashiCorp is focused. So if we can provide that system of coordination that enables for this self-service API-driven automation, then we feel like we will be doing something very valuable for the industry and for our customers. And so it's a multi-layered impact. So people will change their skill set. They're not going to be so technically siloed. They're going to be more about the domain. So if you're a Cisco expert, you're going to broaden that to become about networking self-service. You know, if you're a security expert, you're going to expand that domain a little bit and take a look at how do we handle cryptography for tokenization as an example, or encryption as a service, or things like identity management holistically for the firm. And then I want to have processes then that are focused around that self-service and workflow style orientation. How do we deliver these things as a dynamic service? And so the system that underpins that is going to be focused on having an API-driven and a collaborative approach. I want to make sure that security is involved, as an example, with policy for provisioning. So moving away from tickets to APIs, and the reason that this is, we will refer to this as a system of coordination, is if we're talking about having an API-driven system for how do we issue credentials to an application and audit them and so on and so forth, I will have the operations team handling things like the automation, the backplane that actually operates all of that. And the security team will be coming in with sort of policy definitions that we would then codify through the system of coordination, so that when the developer team requests access to a system, we're still enforcing all of our best practice and policy. We still have good, clean audit. However, behind the scenes, we're all sort of collaborating to make sure that that self-service is inheriting our best practice and is meeting all of our audit requirements, et cetera. So I'm going to move really, really quickly through this because I do want to save as much time as possible for ahead. As we talk about the individual layers that we serve as HashiCorp, we start with this concept of infrastructure as code. And the idea is that if I write the code, generally speaking, Terraform has like a 3-phase process for rolling infrastructure. You write the intent of the infrastructure deployment, you plan it, it runs a plan phase, and the plan phase actually goes out into the infrastructure to see what's actually running, to see how close is the existing environment to what you asked me for. And it will come back with a series of changes that it would recommend to make the existing infrastructure look like what you asked for. And then finally, you have an apply, which says, okay, yes, I agree with all that plan output, and I'd like you to go ahead and implement. So when we say infrastructure as code, that does a number of things for us. One is it gives us an audit plane for how our infrastructure intent is changing over time, because I can treat it like source code. I can check it for diffs, who made changes, when, how, what happened. And then I have this plan as another form of audit where I can take a look at that plan output and I can apply policy to that plan output before I actually allow things like an apply to take place. So now I become collaborative. Operations team is writing code. We're overlaying policy on top of that code. It's very tightly controlled in source control. And so we end up with a very clean way to automate, validate that the infrastructure is meeting our expectations, and provide clean audit. And then Terraform makes things easier because there's a huge ecosystem around Terraform, building all these providers, allowing us to simplify our interaction with AWS, as an example, by having an AWS provider. So I just issue 3 or 4 pieces of metadata, and I can get an AMI or a VM or a VPC stood up or so, those types of things. And I'm able to do that through the public cloud provider. Additionally, though, we're working with more than 270 other providers on top of the public cloud providers, which allow us to do things like provision things like Datadog and Git and all of those other kind of good, exciting things that developers want to consume. So I have these nice, clean providers which make it simple to interact and provision all of these things in whatever public cloud or private cloud. So vSphere is also a cloud technology. If you're gonna deploy to vSphere, there's a vSphere provider, and I can provision whatever infrastructure I need onto the private infrastructure as well. So I want to bake that competency, if you will, into a nice clean workflow that allows me to manage it to our operational best practices. And part of what infrastructure as a code drives is the split of execution from the definition. So I have an idea of the intent of what I want to do, and then I have the actual execution. And then it's scalable. Because it's just code now, I can call it and invoke it and run it anytime that I want. So I have a dynamic exercise. If we extend this into security, we typically have this kind of concept where your client code would need user ID and password to a database, and they would ticket the DBAs, they would get Scott Tiger to access Oracle, and then they would embed Scott Tiger into their source code. So then I've got that secret is going to be sitting in my source control repo. It's going to be in my APM solution, which is monitoring, kind of performance of the application at runtime. I'm going to see it dumped down in logs for when the request was made and what the timing was, et cetera. So I end up with these secrets kind of scattering. And that seemed to be acceptable when we had this high trust environment inside the data center. But that's no longer the world that we live in. As we talked about, that principle has shifted. So I need to have a way to abstract the concept or the issuing of that new credential. So I'm going to have Vault validate the identity of the requester, and it's going to look to see if there is a policy which allows for the access of that system by this other system or individual, human, system, really doesn't matter. But whoever's asking for access, I want to validate that that identity is there and that I have a policy that allows that connectivity. And then rather than giving you the user ID and password in plain text, I'm going to send you a token, put that in source code. It can scatter around, but all you're seeing is a token. And from that simple workflow of managing that sort of indirect access to the backend system, I can begin to add additional layers of value around that. So why couldn't I also encrypt information as it gets shipped to the database and have Vault do that for me? Absolutely. I'm already going there for the ID. I can see that there's a policy for this to be encrypted. It encrypts it and writes it to the database and encrypted, and it passes the application back ciphertext. So no one is being exposed. And then we can get even more elegant around that by managing the lifecycle end to end. So there's not even a credential until the call is made, and then I'm going to create the credential. So there's a lot of really interesting things that we can do around security as we introduce something like Vault to the scenario. And ultimately, there's a lot of really interesting things we're doing here around what we're calling format preserving encryption. So you may want to have a social security number that is has the right number of digits and the right format, but I just can't have it be the actual customer social security number. So scramble that for me and send me back the appropriate format so it doesn't break my systems, et cetera. So again, that's that workflow of request, assert my identity, there's an attestation process with Vault, which says, yes, that you are the person who has access, and then it will manage all of that interaction for me as we go forward. Again, very hard to separate networking from security. And so we get into, okay, but what about firewalls and access rules and things like that? Well, it gets much more complex as we move into containerized workloads and microservices architectures where we're dealing with hundreds and hundreds of thousands of services running live in production and moving all the time. So now I maintain a firewall where I've got 2.5 million firewall rules. Well, one of the ways that we can do that is we can implement a registry service where the services register and then they get health checked using the console registry. And then I can have things like my firewall subscribe to the console registry so that as things move, the firewall can update its rules dynamically in response to what it sees in the registry. So if I'm health checking an individual service and I see the service is no longer available, it gets removed as a viable node inside my registry, and the firewall can pick that up and update the firewall rules. Here's the new IP that can be talked to, et cetera. And I manage this much more, rather than trying to manage 2.5 million firewall rules, I'm managing a fraction of that in intent-based rules. So my web server can talk to my database would be an intent access rule. And then the IPs can be bouncing in and out of those two identities. But I keep a managed access between those two. So again, scalable, independent, dynamic infrastructure is going to require us to think more in terms of identity instead of IP. And we're in a much more zero trust footing than we are in a high trust footing, given the realities of multi-cloud. And then this extends, once again, from that simple concept of having a registry that I can then base my networking and routing logic against that registry. I can then start to do some very interesting things as we move into true service networking, service, by service name or identity. So the idea here is we really get into more of that service mesh concept. And for those of you where service mesh is a bit new, the idea is when I deploy my application asset, the access policies sort of travel with that asset in the form of an agent, and I won't get too technical at this point, but a sidecar process where all of the calls for external resources go to this local proxy, and this local proxy will vet, do you have, is the policy in place that allows you to connect? Does it require mutual TLS? Should I go get a 509 certificate, right? All of those things are asserted at the time that the call is made dynamically in runtime. And so in this way, we start with this kind of automating network middleware, and then we begin to look at securing multi-cloud networks, no matter how my services are provisioned or where. And so that's really where Console plays, is to help us move from the traditional approach of managing firewalls and big IP and all of those kinds of, in a manual ticketed siloed process, and getting much more into that process domain automation for how we connect services in general, and automating a lot of that for us using Console, starting with the registry, health checking those service endpoints, and then dynamically moving things around. Finally, as we talk about application resources, and then I'll turn it over to Ahead, moving as quick as I can here, then we have this concept of pushing applications in smaller, more modular, consumable containers. And typically we have this concept of either requesting things like a Kubernetes cluster to be stood up, and then I kind of exercise against that kubectl command line, kind of interface for deploying my applications. But I may take another step here and look at, that's really true if you're talking about only containerized workloads on a Kubernetes platform. But generally, as we look at it as HashiCorp, we see scheduling of an application workload is not just for containers, it's really for any kind of workload. And it becomes a nice, clean interface between the operations team and the development team. So I can have all my operational due diligence in the operations side. So I may want to retire 10 servers out of the fleet and bring up 10 new servers or patch systems or those types of things. I'd like to be able to move all of that stuff around without impacting developers and their existing workloads. And then on the other hand, I have the same concept of the deployment is defined in very simplistic code as well. So I have this intent, very similar to the way we were talking about infrastructure provisioning. We're applying a lot of the same principles in terms of application provisioning. And so I want to define what it is that I want to do with the application. I want it pushed in this number of instances. Here's an auto-scaling policy I'd like to enforce. Here is, I'd like it to be blue-green or canary style, or this is the kind of rollout I want the application to do. And then meanwhile, the operators are kind of abstracted away from all those individual requests. They're just managing the fleet, and the developers are scheduling their workloads across that fleet. So really, I'll stop there. There's some really interesting use cases around all of this, but I'd like to turn it over to Ahead to really begin to dig in on practically how some of our customers that we've worked with together have been able to incorporate these concepts into their world in a real pragmatic sort of fashion. And so let me turn it over to Tim.
Thanks, Michael. Can everyone hear me okay?
Sound great, sir.
Okay, fantastic. Okay, you should see my screen pop up. So as Michael said, we are ahead. I'm going to go over, some good practical examples here, I think, and just sort of our take on some of the concepts that Michael established. My name is Tim Curlis. I'm the Chief Architect for DevOps at Ahead. I've been at Ahead for about 9 years. I focused in the beginning of my time at Ahead in more in the infrastructure space. So I've got a pretty deep background in virtualization, and then also moving to the cloud in the early 2012, 2013 timeframe, and helping our customers understand primarily how to use automation to their advantage and how to leverage automation moving from on-premises into the cloud. So that's kind of the background for me and where I think some of this will come from today. And just in terms of DevOps, to use an overloaded term, in terms of the DevOps movement, these are some of the things we're seeing that are causing slowdowns and hiccups along the way. Typically not all of them for everyone, but usually you can identify with a few of these on here. Certainly the hair on fire concept, the idea that we're always putting out fires and closing trouble tickets and addressing operational deployments and things like that, just with a low amount of automation that causes really a lack of time to do anything else and really innovate. Certainly cultural challenges and silos, lack of success criteria. Infrastructure of code really is what we're talking about to kind of combat the no version control concept. If you have, the way it's done is on a laptop and is in a Word doc, it can make things very challenging, especially as you try to move forward more quickly. Security being out of the room certainly causes things like this. And then also past implementations going poorly, things like Agile. A lot of times we'll see this where if somebody had a really poor experience implementing Agile, they're just sort of afraid to continue on and new things like DevOps and SRE. So we're going to talk about some of the things that the tooling as well as the people and process changes can really bring about to help combat some of these and get initiatives back on track and move more towards business success more quickly. First, just a quick background on Ahead. So we're an enterprise consulting group. We are basically headquartered these days in Chicago and Atlanta and Nashville. We have offices, as you can see here, pretty much everywhere east of the Mississippi, and certainly have customers that span the entire United States, North America, and even some internationally. So we're a little over 600 people. Most of those people are technical, either delivery folks, consultants. We run pretty lean on the sales front and pretty lean on the operational front. So a good 350 to 400 of those folks, if not more, are focused on technology and helping solve problems. We have a focus in the mid to large enterprise customers, and obviously a very heavy focus on our partnership with HashiCorp, as you can see there. So, and you'll see some of our solutions and how we think about this, but it's all about the stitching, right? It's all about bringing these things together. So the 5 kind of key focus areas for us, obviously relentless automation. Sounds a little overzealous sometimes, but it's this idea that if it can be automated, let's think about whether or not it should be, and move forward to hopefully use that automation to drive more consistency and more time, faster time to market, really. Modern applications, we it's not just infrastructure, it's also the platforms and the applications themselves. So helping organizations understand what their API strategy could be, data pipelines, how to develop greenfield and refactor existing applications into more of a digital cloud native sense, are very key focuses for us. And of course, enterprise cloud being where we run this, right? And this you'll see in a few moments can take many shapes, but The enterprise cloud is the operating model that Michael just talked about. It's how we run this, irrespective of where it physically lies, right? It should be a common model that is the same approach, whether it's on premises or in Azure, AWS, Google, wherever it may be. Scaled DevOps, is this idea that a lot of DevOps up until this point has happened in kind of small teams, and sometimes is a grassroots-led effort, and it's this idea of how can we make this an enterprise focus and enterprise practice, and really start to turn the needle more quickly in terms of the people, process, and tooling. And then, of course, integrated security and our security practice, really trying to bring all of these things together and be very relevant in the room when it comes to bringing the customer security teams together so that we protect shareholders' interests and intellectual property and all of these important things while also getting to do kind of the new and fun stuff in DevOps and Cloud Native. So obviously they're multi-year journeys, but this is our focus, bringing this all together. And really expediting speed to value, right? So as I just quickly build this out, it's a lot of automation, developing new ways of working, and just hopefully in helping to evolve continuous delivery, so that we recognize the business is uppermost, and it's typically applications and data that help the business succeed. So it's how can we deliver those things faster. And we focus, everywhere from a run standpoint, any cloud, any platform, generally any application stack. And some of the themes around just day two operations, monitoring, a lot of automation through the build layer and in the innovation layer with things like Cloud Native and CI/CD, really focused again on the application at the center. So bringing it back to the enterprise cloud operating model, I kind of hit on this already, but we're starting to see organizations obviously have had a focus on local data centers, typically whether they own them or their co-locations, and trying to figure out what that model looks like. They're also starting to invest, and in some cases investing heavily in public cloud, and I would say almost just as heavily into SaaS solutions where it makes sense, right? But then for certain verticals, some more than others, and I think eventually everyone, there's also this question of edge computing and IoT, and how this dispersal of where this stuff runs, and how we kind of get our data and information back to the business and back to the developers. So these are all crucial pieces that the workload itself drives these, but we want to have this common operating model across all of these. And I think consistent with what Michael talked about, and I think everyone can probably relate to this, if not tell me that they experienced this today. You may be in the cloud, but you're typically still doing these requests whereby a manual order is submitted and then passed around. And what we've seen over the last few years is automation has really taken off in each of these colored areas and has become very efficient, but the transition between the areas is still a significant slowdown. And so the server team may clone a virtual machine from a vSphere template or an AMI and be done in less than 20 minutes. And then going to create some DNS rules or open firewall ports, that is another probably 30 minutes, but it's the transition of that ticket and it sits in the queue and who takes ownership of that can take days, right? And all of these things sort of add up. You saw the one example from Michael, and what we see is very consistent, right? I think 18 to 20 days is not uncommon to get these workloads. And the more we move toward rapid deployment and wanting to deliver features faster and doing things like containers and serverless, those models just become a huge impediment to speed, right? And in this provisioning process, the request comes in, and this flow time is kind of taken from it's from an individual who wrote this book. His name is Mick Kirsten, and it's really focused on first there's the customer request, and then it sits in this prioritization queue, right? And if it's a new project, there may be a lot more to it, and you may be creating a huge development environment with QA and non-prod. All of these things get prioritized differently if it's sort of one-off requests, and they tend to end up in a large bucket. Maybe something like a PMO steps in to help, but there's time lost to that prioritization process. And then once the request is picked up, there's various active and waiting times that we sort of depicted on the slide with the paper going around. And that is, again, if a group is working on it, it's active, but then there's this waiting time as emails are passed back and forth, or a ticket sits perhaps in ServiceNow. And so it creates this idea of flow time, and then this idea of lead time when you include the prioritization. But at the end of the day, the developers just, they want to write code. And I liked how Michael sort of talked about it as enabling the developers so that they can focus on, solving a business challenge in that respect. And some of the observations we've made over the last couple of years, probably 3 or 4 years, provisioning process again here, one of the things right there is it's a lot of times focused on provisioning and not deprovisioning. So this idea that people are creating a lot of things, but then they sort of rely on outdated or maybe no process at all to figure out when things can be deleted, which leads to a pretty heavy life cycle, kind of reconciliation matter. But in terms of sprawl, things like too many standards, especially as we go to the cloud, there becomes many more standards typically. Life cycle, everyone is to the point where we wanted to introduce leases, and that's really come from the fact that the cloud experience, right, that the cloud providers have left us or led us to, and wanting to bring that into other like on-premises environments, for example. Certainly we covered the handoffs, just so many manual steps there, lots of handoffs still happening. And then inconsistency is another big one. I've certainly had customers say, we don't build stuff that often right now, but we can always ask the follow-up question, how consistent are they, right? How confident are you that all of your 20 SQL servers are identical, same security settings, same firewall settings, same CPU settings, et cetera? And then, multiply that across all the different workload types. So consistency is a really crucial thing that we want to look to address. Visibility, teams tend not to have all of the information all the time, and that maturity varies. If you're typically sending emails back and forth, that's going to be at its worst. But if you're using a more modern request system, you may have notes in there. But the idea is, even just catching up on that stuff in the ticket can really slow requests down. And in the case of ServiceNow, just kind of like limited visibility. So, and in terms of the provisioning process, we talk about silo excellence, where we're getting to the point now where the teams themselves, internally are really starting to create some great automation. Infrastructure is creating excellent automation around creating virtual machines, maybe some container workloads. Network is starting to use things like Ansible to automate perhaps, firewalls or something like that. Developers are using automation to do testing, right, and to deploy code. Et cetera. But what we're really kind of lacking is what is the automation of the business process across all of those units to create an overall outcome, right? That the focus is more on the business goals instead of thinking, hey, I'm just creating this VM. It's I'm part of this overall process to create this workload to provide a business service that's brand new for our customers. So we call it silo excellence, and again, it's how can we break out of that and extend that or get beyond that, I should say. So to address that, we've really got to focus on 5 key areas. First, obviously reducing manual steps. The processes that Michael talked about that I'm going to sort of talk about as well here, focus on driving more automation and driving more standards through infrastructure as code to really try to reduce those handoffs and those manual steps. And certainly automated integration with things like ServiceNow so that people aren't necessarily creating change tickets, but all the information is still logged, right? So that those happen in a more automated basis. Secondly, reliability, just, the more we use infrastructure as code and create those standards and we're spending less time, just putting out fires, that reliability can increase. That's really what's sort of brought about the you build it, you run it movements into things like Google's SRE concepts. So you get the same experience, the same outcome every time. And really these things leading to a faster time to market. Again, if we're doing things manually and we're always behind, the time to market suffers, but if we add more automation and we use these standard approaches, our time to market improves and increases. Visibility, obviously, just within our tool chains and our practices, but also across involving, again, things like the operational side, monitoring, and just having this understanding of what these patterns do from what the customer experiences when they click a button in an app, for example, to what the patterns of use are in the cloud and on-prem platforms, which then of course drive things like costs. And so all of these things are interrelated and drive more visibility. And then lastly, satisfaction here. I mean, obviously satisfaction to customers, but even satisfaction to our internal teammates. I can't tell you the number of times we hear developers went rogue because infrastructure was taking too long, or security wasn't invited to this meeting because all they do is say no, right? And it's some of the things that we can learn from what the public cloud providers have done and bring that into our operating model to try to bring some of those same experiences, which then will increase satisfaction and you know, make this all a better place to work, so to speak. So our approach really focuses on better software faster, and the approach is twofold. One is what I like to call the hardware side, and that's developing your enterprise tool chain. There's core tenets around microservices, containers, obviously public cloud, and then CI/CD as well, and ensuring that aspect. But just as importantly is the DevOps dojo concept, or your center of excellence, some call it, but really the people, the process, the tooling. And as we'll see, you know, if you don't change some of that and shake that up, you're going to sort of be doomed to fail from the start. And so Ron Westrom puts together this body of work, but I always like how Adam Jacobs sort of sums it up, that your org structure isn't solving your problem, it's an artifact of how you've solved it before. So in other words, we find that, you know, not a lot of organizations are fully pathological on the Westrom spectrum that you see here, but sometimes there's aspects of this where, you know, they fall into the pathological categories and maybe more in the bureaucratic side. But what we're finding and research is showing is that the more we sort of bring the teams into a new way of thinking and doing this, Michael talked about embedding the SRE, you know, that's a great example. The more we get, you know, sort of this performance-oriented generative culture with more cooperation, more trust, shared risks, and that sort of thing. So this is a very important piece of the overall puzzle. You know, it's something that can't just be solved by buying the latest and greatest CI/CD tools, for example. And this new culture really starts with building empathy. So, you know, the application developers need to build empathy down the stack as they're understanding what the infrastructure operators go through to support the platform, and vice versa. The IT operators need to build up the stack to sort of understand what the app developers are focused on in terms of automation and testing. And we have this sort of duality of what the primary passion is and then what the empathetic focus is. But it's important for this sort of you know, empathy to occur, to be supported and built up, to really change the culture and the mode of thinking to be more in this DevOps mindset. And it ends up being that we're looking at more than just human requests, right? If I have a, you know, sort of standardized approach for getting a system development environment, and every time the developer needs to do this, they have to go fill out this form. You know, obviously, if the form, you know, takes me 10 minutes and then 30 minutes later I have my dev environment, that's a huge success. But it doesn't mean we should stop there, right? If that right there represents a lot of automation that goes into creating that, and there's a lot of benefit to all the teams that are involved in creating that, because now this automation takes a lot of the work off their plate, the really mundane stuff. They focus on a pattern, and this is turned around much more quickly. But the benefits there is if we can also expose these, not just by filling out a form, but maybe through an API request, then we can do more repeatable, more frequent actions, and things like tying it into a CI/CD tool chain, such that I use that same automation to get like a blue-green environment or a canary environment or a test environment. And we do that, you know, through different ways of presenting the request, but not by changing the underlying automation, right? So we solve that problem once, and then we just use it in different ways. And then the third, of course, being kind of the newest, latest, and greatest self-healing requests. So plugging in, like Michael mentioned, Datadog, right, where a tool that can sort of understand when a user clicks this button, it takes, you know, several seconds to go through these requests and then hit this data volume. And here's the issue with that. It can actually not only understand that alert, but trigger some specific response through more than just an email, right? If it pages somebody that's not really that helpful from an automation standpoint. So those tools can also do maybe an HTTP RESTful call into this automation to provision additional capacity or take other sort of remediation steps. And again, it's reusing that same automation underneath. So the idea of connected pipelines becomes really important to this. And we found this early on because we were helping really the areas in infrastructure understand we need some sort of request management system to get requests and sort of focus them and govern them, maybe set leases. And then we need something in the middle that does orchestration deployment, right? All of the things in the environment like installing backups and setting up DNS and setting up firewall rules and opening and closing change tickets. And then something like configuration management, which governs the workload once it's been created. Something that can address drift. It can go inside the virtual machine or the container and create certain settings, registry settings, drive mounts, user permissions, that sort of thing. And all of these things come together to create this sort of end-to-end automation. Really, the things that were embodied in like a Word document up until that point, where somebody would clone a virtual machine, but then they'd spend a couple hours going through this 6-page Word document to get it set up the way it needed to be for the organization. But at the same time, we were finding development teams are creating CI/CD tool chains where they're focused on doing automated testing and deployments more quickly. But a lot of times they were going out to a new cloud provider and maybe quickly spinning up some Kubernetes cluster. And it's sort of like, why can't we build more empathy and work together and combine these pipelines so that we get a standard outcome on the infrastructure space to run and be more agile for the developers. And of course, with this comes incorporating service management. So if we can, both of those pipelines can insert information into the service management tables, like your CMDB, your change tickets, your incidents table, your security incidents table, then we can sort of inform all kinds of other parts of the business, not only between development and operations, but maybe marketing, right? They want to see, how something's going with a certain feature so that they can time a press release, so they can time a commercial campaign. Maybe the help desk, we want to give them a heads up. We've all had that where the help desk starts fielding calls and they don't realize the problem is sort of already underway. And it would be great if when they look back at incidents or in the CMDB, they can sort of understand, hey, this we just pushed a new version, or this blue environment is now the green environment, or vice versa. So having that information in service management becomes really important, and doing that in a very automated fashion is also very important to people's just mental well-being, not having to do that manually. And just, obviously example enterprise tool chain, but something that'll kind of set up the next few slides. Obviously these tools are very, they vary widely between different organizations, but using something like Terraform for the infrastructure as code piece becomes very crucial. When you think about, I have my application code, I can pair with it the infrastructure code. So the two together, one deploys the app, one deploys the infrastructure, I guess in the opposite order, but that becomes a very powerful pairing where everything is sort of standardized as code. And then something like secrets management with Vault, as we're going to see in the process here, and how that, leveraging that as opposed to hard coding and passing these values, not only becomes far more secure, but also becomes much more flexible and easier to deal with, less hacky, so to speak. So, modern kind of example automation architecture that we do, and is basically starts with a request being fielded either on the top left from something like ServiceNow or a catalog, right? Even you can think of it as a cloud portal. And then the bottom left being more like the developer submits code, and the GitHub or whatever has a hook there that triggers like a Jenkins job or an Azure DevOps job. Both of these things sort of leverage this integration hub to say, okay, I need to do something based on this request. So I go off to my tech orchestrator, and that's where something like Terraform becomes very powerful, because it starts to reach out to all of these different cloud providers on premises, whatever they may be, and spin up the infrastructure components to start laying this code down. But it does it in a way that's very, focused for the enterprise, right? So if I have a Kubernetes cluster, and I want that to look the same each and every time, I can develop this Terraform module that all of these workflows can then plug into. That way, team X isn't doing Kubernetes manually and differently than team Y. And then, oh, by the way, security has to check both X and Y because, it's not based off of a pattern. If I can base this off a pattern that security checks that, for example, then, all of this becomes much more reliable and much more agile to sort of integrate into this process. And then, of course, handing off to something like a Puppet or a Chef or Ansible to do configuration management. So now, Terraform has laid down all of these pieces in the cloud, and having Puppet come back and sort of install packages, binaries, dependencies, et cetera. And one of the things that we've seen and architected and offer that I think enterprises, it's interesting, right, is this idea of an application stack delivered as a sort of fully encapsulated service. So the example we do, here is think of maybe a developer using something like JHipster or the Spring Initializer if they're doing Java, where they fill out a few fields and they get basically a zip file of like some boilerplate code. They can unzip that and immediately start writing their code. So think of that, but more on steroids. So they go to ServiceNow, and then there's this portal they can pick I'm doing Java, I'm doing Node, I'm doing React, .NET, Core, Python, whatever it may be. And then they can optionally say, I also need, a Mongo database, or I need a SQL server. And the nice thing there is they have some flexibility and choice in terms of sizing and technologies. But it's not like it's completely wide open to the point where we have embedded stuff. Like if they go into a cloud portal, suddenly they could start using, I don't know, Redshift in AWS, for example. And as great a tool as that may be, the enterprise may not be ready to support that yet. And they haven't gone through this process of, what's the tagging strategy? What's the accessibility strategy? What's, our data, is it secure? Is it safe? So by sort of ratifying those things and adding them in, you gain some of that control. And it's, to Michael's point, it's those guardrails. But you're enabling the developers to very quickly get that environment. So they click submit. You see the example here, the example here pretty much leverages Azure DevOps. It could be Jenkins, it could be other things, but it goes ahead and sort of boilerplates out, a code repository for the app as well as the infrastructure piece. Sets up a Vault workspace, so they have a specific safe spot for their secrets that's unique to them. They have, testing that's automatically integrated into the pipeline. They have a registry for containers. They have boilerplate deployment pipelines. They have a workspace created in Terraform for the infrastructure pieces. There's a Slack channel that's set up, and there's application created in App Dynamics, for example. And all of this stuff is boilerplated out, as well as Terraform actually deploys, a dev, a test, and a prod, for example, or a blue and a green, for example. Maybe it's a pair of virtual machines, maybe it's a small Kubernetes cluster. And based on what the user picks, it gets deployed. And so you're not looking at an infinite number of permutations here. You're looking at what has the organization sort of gotten their hands wrapped around, and these are the couple clouds you support, these are the couple languages you support, and if that works, great. And if you want an additional one, drop a request in, and we'll be able to sort of work through that and field that in the future. And in another sense, continuous deployment. So the previous slide, I think about, if I have a new team that comes together to create a new business service, maybe write a new API, it's probably not something you do daily. It's more something you do every couple of sprints, perhaps. This, on the other hand, is your CD pipeline that probably happens several times per day. And so the sort of grayed out is this idea of the CI process, continuous integration. It's sort of, we're not going to cover it here, but a developer commits code and goes through, does testing, and eventually builds basically a container. And in this case, puts it in Docker Hub. So now my CD pipeline picks up, not based on the code commit, but based on the new artifact being there. And it can go through and sort of hook into these tools. So for example, before I deploy to dev, I'm going to actually use Terraform to invoke the dev infrastructure as code for this application and give them a fresh dev environment. And that's not something that has to be a manual ticket. It doesn't hand off and say, hey, go open a firewall rule. Terraform has all of the capabilities declaratively to say, here are the 5 VMs, here's the MongoDB, and here's the Kubernetes cluster. And it may take 20 minutes to spin that up, but a person doesn't have to lift a finger. And oh, by the way, all that stuff was entered into CMDB, and change tickets were automatically approved and were up to snuff on documentation. At the same time, we can get keys from Vault that say, what account should I use? What's my accessibility key for an API? That stuff is all handled. It's all encrypted. It's all rotated for me, and it's all very, very secure. And then that pattern, done once, can be stamped out with a small, tweak of a variable to be my QA, to be my prod, my canary, my blue, my green, et cetera. And then the CD tool, again, it reached out using infrastructure as code, built up all the infrastructure. Now my CD tool can lay down the latest artifact that triggered this in the first place and go ahead and start to run some tests. And that's where something like console will automatically see, okay, my environments have come up. We've gone through and used the modules specific to my enterprise. So I've integrated them with our console instance, and automatically I can call again, because we're not focused so much on individual IPs that are very changeable. I can start to call these services like dev.app.a.whatever, qa.app.a.whatever. Those services register themselves underneath that DNS endpoint very quickly and very automatically. So all of this, obviously we're just scratching the surface here, but all of this stuff becomes very, very automated and very standard to enable that development team to really get going quickly. And I just want to wrap up by talking about this concept of maybe defining a tool chain, but not forcing it for everybody. And what we like to see is dead center in the middle is your dojo, your center of excellence, the various disciplines come together and they listen to the use cases, everyone gets their voice heard, and they build the tool chain that hits the most use cases they can, 80%, 85%. And they say, here, if you use this, you can come in, we'll train you. If you're a new hire, we'll help you, we'll set up your instance, we'll enable you, and we'll support you. It'll be our product, right? Our product is these tools and this process stitched together. But then on the left, you sort of have this area for experimentation and choice. That way, people that aren't necessarily covered in this tool chain, they can go and they can verify if there's a new database technology or a new streaming technology they need. They can sort of build that case in this safe experimentation and choice area, with the understanding that it might be a best effort support, and you're sort of building that operational excellence as you go. But you have a process to ratify, to provide that feedback into the product team. And then as a product team, they can say, okay, in the next version of this, we're going to add this tool, sunset this other tool, and that's how we'll get that in there. But of course, then we want, obviously, underlying all of this, the information and platform security team to really have a process for vetting and verifying and building these safe spaces to protect the business, not just completely allowing anything and everything. So it's all about a balance, right? It's a balance between providing flexibility to try new things, but to also protect the business and keep things agile and moving. And so this is the process that we think and we've seen work, and we'd love to talk and go into more detail on. So I'm going to, at that point, pass it back to the team for some Q&A here.
All right. Thank you so much, Tim. Thank you so much, Michael. As Tim just mentioned, we have some time for some Q&A. We did receive a couple of questions that we'll start with for our discussion, but for members of the audience, I encourage you to use the chat or the Q&A function to enter any questions you have for our panelists. Let's see. All right. Michael, first question for you. I think this will be a good one for you is, what other types of self-services have you observed other operation teams delivered aside from infrastructure, security, and identity?
Yeah, so self-service is one of those really interesting topics. We can talk about it from a number of different perspectives. Certainly, we would see things like any sort of SaaS provisioning, any sort of in addition to things like identity, we could talk about things like encryption as a service. These are all obviously capabilities that we see people require, especially for at scale, to have things dynamically provisioned. But ultimately, you could be delivering things like databases as a service, analytics as a service, answers as a service. Some people look at, like, you're not actually going to provision any infrastructure, you're going to ask questions and we'll serve you with an answer kind of thing. So it depends on how you define what that thing is that you're going to self-serve. HashiCorp specifically is obviously focused on the provisioning, security, connectivity, and scheduling as the primary forms of self-service that we look to drive, but they tend to be enabling technologies for any of those other domains. As an example, Citadel runs these huge Monte Carlo risk simulations for stock trading markets and things like that. And so they provide kind of as a service Monte Carlo kinds of representations by spinning up 40 million cores to deal with a very large risk analysis, and then return some results and then flush it all away. Which is a great way, by the way, for the company to capitalize on the cloud, kind of the cloud cost model. I can get 40 million cores and throw them away 5 minutes from now, assuming my query completes, and not have to keep them all up and running in a private data center. So that type of thing would be another form of kind of as a service. Is there any that you've seen, Tim, as unique?
Yeah, one of the things I love that I've seen a few folks start to do is like a suggestion box, right? We can only automate the priorities that we see and know about. So if we have, create a VM, create a database, create a firewall rule, we can prioritize that and sort of eat through that backlog. But there may be a totally new idea out there that we're not even aware of. And I think having that suggestion box is really kind of a cool, simple way to intake, like, what would be helpful in my line of work, what would be helpful for me delivering value to the business. And then you can sort of add that to the backlog and start to prioritize it.
I love that idea, Tim, as well, because it goes back to that empathy charge that you're
Absolutely.
seeking, is to have it be collaborative. We're not here to impose on you as the developer audience. We want to hear from you. Here's how we collaborate, share what you need, and we'll automate it. We'll drive self-service.
Absolutely.
Great. Tim, a question for you. How have you seen other customers get started on unlocking their own cloud operating model journey and successfully adopting the HashiCorp solutions? Where do we get started? What's a sign of success?
Yeah, it's a great question because it can be challenging, and I think one of the biggest things is going back to that first slide about your hair is on fire. It's sort of like, where do you start? And what we've seen, I think, is sort of pausing, taking a breath, not for too long, just for maybe a sprint, to kind of come up with, okay, what is our stitched together vision? What do we already, first of all, what facets of this problem are we trying to solve? Then we start to plug in, okay, here are the processes and tools that we already have, and that'll start to show us there's overlaps and things we can maybe get rid of. It'll also show us where the gaps are. And then at that point, it becomes, let's do a prioritization exercise and just sort of see, okay, here are the things that we know about that are taking the longest, are the most mundane. And it's sort of like they rise to the top. And that's where, if we can just, get 1 or 2% of our time to start working on those, hopefully after a sprint or two, we'll have one of those done. And then we can just go down the list, and that pendulum shifts from my hair is on fire because I'm closing tickets all day long to, now I actually have some time to do some project work and do some innovation work. But I think it's setting up that stitching and prioritizing that out first that, can sometimes take a month or so, but, just focusing and getting started on it is really beneficial.
Are there like measures? And sorry, I know this is kind of off the cuff, but I've had this conversation with a few leadership teams around measures, and I have a few ideas, but do you measure ticket times to prove value? Is it like a before and after? Here's what it takes for us to get to market now, and after this innovation, we're able to drive out X% of drag in the system, or what have you? Like, what works for y'all?
Yeah, I think some large strategic engagements will do that. We'll come in and a more of a consultative basis kind of build that out. But a lot of customers in our experience just don't have the ability to collect on those metrics and understand what my starting point is, to understand what my ending point and the hopefully benefits are. So, I mean, a lot of times it boils down to just request time and maybe things like how much downtime, how many outages are we seeing?
Sure.
But, I think it's just getting started sometimes that is more beneficial than anything else.
Yeah.
All right, Michael, a question that I'd like you to start with, and then Tim, you could chime in after. Can you speak a little bit on a high level of the differences or similarities of some cloud networking offerings, something like a Cisco SDN cloud, as compared to with what Console delivers? Anything that's the same, what's different, what makes Console stand out to these other offerings?
Yeah, I'd be curious to Tim's thoughts as well. I generally think of these different approaches as sort of coming from a traditional networking standpoint or coming directly from the service mesh. So you have network vendors like Linkerd as an example, which are a good kind of service mesh, but they're only in the cloud and only on containers kind of thing. They really don't have a view towards sort of the legacy infrastructure side typically. And then we see something similar if we're coming from like the Cisco SDN, software-defined networking, or like NSX from VMware, et cetera. The approach originally was sort of define your IPs and your network topology and then push that into the cloud so that my IPs could remain fairly static and I could maintain a legacy network footing approach, I would say, operating model in the cloud, more dynamically, more self-service, more automation, more of those kinds of things. And then those over time are maturing closer and closer to a true kind of service mesh. There's now service mesh capabilities for NSX. There's a lot of really interesting innovation around this space growing into a zero trust network footing. What I really appreciate, and I'll just roll it back and say, I try to see the industry on kind of that spectrum, the all-in innovators, which are kind of only in the new, the traditional players who are working into the new and migrating their existing offerings into the cloud, to expand their reach and capability. It's one of the reasons why you see F5 purchase like Nginx. They know we've got to be software driven, and that's a big move for that firm. So as we talk about those kinds of things, what I really love about Consul, and one of the reasons why I came here, has to do with sort of the simplicity of the approach, the idea that it is a simple binary and registry that acts as kind of that coordinator. We're not trying to do I would say we're trying to do a lot with Consul, but we're not trying to get outside of what we are really, really good at, which is kind of that registry, health checking, automation workflow tier. So we're reliant, as an example, on the open APIs of the hardware vendors to facilitate that automation. We're not trying to build our own device. You know what I mean? I don't know if that makes sense, but the Consul approaches this with a simple binary that can go anywhere that software can run. What are your thoughts, Tim?
Yeah, I like the kind of insinuation that maybe it's a traditional networking team versus a development team, and I think if you're not careful, it can be they speak two different languages, and it can be hard to bridge that divide. And I think some of the culture shifts, the empathy, the dojos, can help bring those two groups together. Because I mean, to me, it's not necessarily an either or. It's more of we have these tools, we have a couple of them, and they do slightly different things, but they are better when you put them together.
Yes.
So I mean, I tend to see like either, what customers do in the cloud is very cordoned off from what they do on premises, or there's kind of a long lead time to getting that connectivity built up. And to your point, Michael, you end up with that sort of edge trust model where we've set up the pod networking, but within the pods, it's pretty open. Yeah. And I think we're starting to see this need for the zero trust model where each individual container or VM is capable of having a security policy, wrapped around that. And I think that's where the offerings kind of complement each other. And, Consul kind of has that authoritative registry to drive a lot of that.
Yeah.
Great. Tim, another one for you to start with. You had mentioned the concept of silo excellence. Can you kind of give us a little more of an example of an organization who successfully adopted it, or what does it look like to embark on trying to adopt that concept?
Yeah, I think, first of all, it's a Mick Kirsten term from his book. And second of all, I think from how I see it, I like the term because I think it embodies a lot of what we see. I don't necessarily think it's something to strive towards as much of it's sort of an eventuality or a stopping point along the way. And so what we tend to see is organization X has an infrastructure team that's really automated at giving you back a virtual machine. But the security team is perhaps not so automated at doing an audit of that. So there's a process to scan that that's very manual. And then an organization over here may have the exact opposite, or maybe the infrastructure team is low automation, but the development team deploys very quickly. They just do it to a totally separate infrastructure that infrastructure doesn't control. And so it's what's lacking in all of those scenarios is what is the business problem I'm trying to solve? Like, what is the new banking feature I'm trying to put out to my customers in the mobile app? That having that organizational knowledge allows you to, so you want to build up the automation in your silo, but you also want to establish automation between those groups and really try to break down some of those barriers. And honestly, the best way to start that process is just to start building out the center of excellence, the dojo, community of excellence, whatever you call it, where you start to loan people, between these teams to try to lend, almost in a consulting way, lend their expertise for their domain to try to build something that crosses those domains.
Great. I think we got time for about one more question here. Let's see. I hear the term service mesh, Consul Connect, and other buzzwords all the time. What does this truly mean? If I'm not embarking down a service mesh, should I be?
Yeah, a couple of things. So this is where we really kind of start with traditional sort of network automation, especially in the enterprise. So once we can establish a registry, we can sort of automate things like firewall rule, DNS assignment, and a handful of other things that get them out of the way of the developer. So what we typically find is that once we've automated the provisioning of infrastructure, we sort of expose some of the networking ticket times. So I was working with one client down here in Austin where we went from, I think it was 6 months down to 15 minutes to provision, get everything they need to run. And then DNS assignment was 3 days. So where traditionally that 3 days was like nobody cared because it was buried in the 5-6 months of other things that needed to take place before we got to it, we kind of exposed that need for automation around, hardware and rules that govern routing tables, all of that type of stuff. So then we kind of start by looking at how do we optimize to drive self-service where we're at, not necessarily jumping directly into a zero trust model necessarily. But what we're finding is that once we've established that general model of having a registry that is that's basically talking to your network hardware, you're a very small step from service mesh. It's not that far a leap at that point. I just need to stand up some sidecars and do a little bit of indirection. And then this is where we see some very large banks, as an example, retire like 1,200 east-west load balancers, because suddenly I realized, hey, all that routing logic is really sort of in console, and where we were doing network protection in depth by having these load balancers indirect traffic, and additional firewall rules, firewalls everywhere and all that, to have a lower trust environment inside of four walls through network segmentation. I realized I could do that all via software, so we could actually retire a bunch of physical infrastructure. So again, I'm not saying go to zero trust as your first step. Ultimately, establishing a registry and health checking is going to provide a lot of significant value just to start if you're not already down that path already. And then at that point, you can evaluate: is this an easy step? Is it a hard step? How do we take one more step into that get zero trust kind of footing? And if the question was, what is service mesh? I'll just say it's the idea where the service is sort of rolling into the infrastructure with routing and policy associated for its own connectivity. So it's not really looking to wait on tickets and things like that. It's the intent and the policy is waiting for it to be received in the mesh, and then it goes ahead and connects. So it's just an idea of highly dynamic connectivity with solid policy enforcement. Anyway, I'll leave it. Tim, I don't know if you want to have any comment, feel free.
Yeah, no, I totally agree. I think the few organizations I've seen that have sort of just a small team over here runs out and sets up Istio, gets itself into trouble. I think having a thoughtful approach to it makes more sense. And there are some very interesting problems it can solve. I mean, we've worked with some organizations on kind of refactoring large monoliths, whereby if we're strangling off certain APIs and they end up in the cloud, and there's this database over here that's kind of legacy, wrapping service mesh around all of that can make the communication a lot, like you said, more dynamic, but also be a lot more secure, right? By providing like TLS, for example, by default. Like if my TLS is a hard thing a lot of times for a development team to do sort of institutionally. So if you want to just establish TLS in one fell swoop across this monolith with all these different APIs, that can be a very, very easy way to accomplish that. So I agree. It's be thoughtful. It's know how the tool is out there and how it works and what the adoption will bring, from a benefit standpoint.
Great. Well, we're coming up to the end of our event here. So I'd first like to thank everyone from the audience for tuning in and learning with us today. A huge thank you, Michael and Tim, for your expertise and taking time to educate us today. A big thank you to Ahead and the entire organization for being a great strategic partner to all of its customers and to HashiCorp. As we mentioned at the top of the event, we recorded the session and we will send it out via email after processing. I hope everyone enjoyed today's webinar and have a better understanding of the cloud operating model. That wraps it up for us today. We hope to see you soon and have a great rest of your day. Thank you, everyone.
Thanks.
Thanks, everyone.
See ya.